All right, so one thing you should be able to do is be able to go from wavelength to frequency and back and forth. So an example question might be to calculate the wavelength if the frequency is 4.62 times 10 to the 14 hertz or per second, right? I think I forgot to mention it in the last video. You can call this as per second or units of hertz. You can call them hertz as well. It's pretty much the same thing. So the equation, right, is that frequency is equal to the speed of light over the wavelength. And so if we think about what we have here, we have frequency right there. We know c is the speed of light, so that's equal to 3.00 times 10 to the 8 meters per second. And so all we have to do is reorganize algebraically. So then we'll get lambda is equal to the speed of light over frequency. And then we can just plug these numbers right in here. And if you take a look at the units, the seconds will cancel out, so we'll be left with meters. And so lambda is equal to then 6.49 times 10 to the negative 7 meters, right? And so we're in units of meters right now. Light, in terms of visible light, is generally given in nanometers. So let's switch this over to nanometers. So 6.49 times 10 to the negative 7 meters. And if we think about our conversion unit, it's 10 to the 9th nanometers equals 1 meter, right? Nanometer is tiny, so there's a lot of them in 1 meter. So we put 1 meter down here, 10 to the 9th nanometers here. The meters will go ahead and cancel out, and then we'll be left with 649 nanometers. And as we'll see the next section, this wavelength of light corresponds to orange light. So if you have a wave, a light wave that has a wavelength of 649 nanometers or that frequency, it will be orange light.